Alright guys, welcome back. So again, we were talking, if you didn't see my other video, go ahead and check that out on my new IR camera, and then in there I'll talk about what an IR camera is, how it works, and how we're going to use it. Now in this I wanted to go into the actual how we're actually going to use this to better our vehicles here, and talk a little bit about the issues that need to be solved here with this Rabbit project and the Mustang project and any other projects that I have that are car related that I could look at this type of imaging. So again, the IR camera looks at the power that it is basically emitting as the third form of heat transfer, which is radiation. It is emitting non-contact electromagnetic waves to the camera. The camera knows its temperature. It knows this Defman-Boltzmann's constant. It knows I plug in the emissivity into the software, so it's just going to use that emissivity, and it will determine the last unknown, which is surface temperature. So it is going to guess or make an educated guess on the surface temperature, and why it's very beneficial is that we can see temperatures, an educated guess of temperatures around in an entire scene all at once, without having individual probes. As long as we don't have something between, right, obviously we can't see the block underneath these wires here because the wires are in the way. So as long as we have a clear line of sight, we can see the temperature difference between objects. The main issue is that this guy is a 9 hertz camera or a 9 frames per second camera. So it is very difficult to capture, to see smooth video here. But we can make some we can make some interesting stuff from this video. So let's go ahead and go through it. So basically what you see here, and you've seen inside the Rabbit multiple times, and I think what I'm actually doing right now is I'm actually focusing the lens on the camera. You'll see that I'm getting these sections very, very sharp. So it's kind of blurry. I went too far, and then I'm going back and I'm sharpening them up, so now they're super sharp. I have it in focus. Sorry about that. Let me get rid of my steam here, to the point that it's so in focus that you could actually see this is the radiator hose, and you could actually see the openings on the radiator hose clamp. So now it's super in focus. And so if you don't know what you see here, so this here are my high pressure pump injector stainless steel tubing going to my injectors. So that's coming out of the high pressure pump. High pressure pump is cold. Here's the valve cover. Here is the block. Here's the radiator hose, top radiator hose. Here's the radiator. Here is the intake, the plastic part of the intake hose on the intake. So you see here that here's the overflow going over to the canister. And again, in the last video, what I mentioned is that whenever I move the camera is constantly adjusting to make the hottest section of the scene the brightest white color, and then it's adjusting everything else to be a different color. So you actually see a lot of stuff change color depending on where I point the camera. That's because it is judging it with respect. So what is that temperature with respect to the hottest in the room? So if I'm looking at this and then all of a sudden I put some sort of red hot piece of steel right here, this will become blue because the red hot piece of steel could be like 1500 Fahrenheit, and it's quite a bit hotter than this. So what it will actually do is change that color. So the bigger the delta of the color, the easier it is to see stuff. So that's why if you have this camera, which I've done multiple times, and you point it in a regular room, it's just blank. You can't see anything because there's no temperature delta between the walls and the floor and the ceiling, and so you can't really see anything. So here it's going to adjust. I was talking about this in my main video, is that we see a really, really red hot hole, which this is my inspection cap on my transmission. So what you can see here is that there is a lot of trapped heat on the inside of the transmission. So there should be some sort of vent holes or something on the transmission to get some of that heat out. So I'm definitely thinking that my next clutch is probably going to be a ceramic clutch so that I could handle some of these temperatures. And you can see basically what's coming out of this hole here. is 219 Fahrenheit, the hottest part in the scene. You can see that here is white, and so we can see here that there's nothing else white in the frame here. And that the transmission itself is in the kind of yellow region here, about 190, 187, something like that. But out of this housing is 217 Fahrenheit. So definitely be looking at that for your new clutch, is to possibly run a ceramic clutch on this guy. You can see there, that's my hand. And my hand is, 98 degrees Fahrenheit. So you can see that my hand is actually black because it's way colder than everything else. Here is another one of the intake hoses. And then what you can see here in the back, I go to the back, this bottom part right here, this is the exhaust manifold. And you notice that the exhaust manifold and the intake manifold are pretty much right next to each other. But this is where I'm very surprised with getting this sensor, something that I did not think I would find. And that is that the intake runners, these are the intake, this is the plastic housing that holds the what's it called, holds the filter in it. That's about 149 or so temperature here, and then these are about 197. So I thought that this was going to be a little bit hotter, but actually 197, that's really hot for an intake. So one of the next things that I think that we should look into is how much is that actually affecting our density and also our intake air temperature, because this is getting extremely hot, and as this air whips in here, it's superheating that air as it goes inside. But we can see here that compared to the rest of this up here is cold. It's about 130, 120, 125 or so. This is probably the darkest set part in the scene. And we can see just through here, this is the exhaust we're seeing in between the intake. So one of the things I'm thinking is that we should definitely shield this exhaust. And I'm thinking that that's a project for when I get the turbo. And you can see here, this is the intake runner going up. Again, 190 to 200 degrees Fahrenheit. So that is extremely hot and very, very influential to the air going in. But you can see that actually the weird thing is that in the back, I think this is just having a weird IR reflection, that the temperature is starting to drop as it goes to the back. And so that's pretty standard of what you see. So pretty much this is after the engine's off. The engine's not running here because the engine vibration would cause even more weird effects with getting 9 frames per second. So it would be very strange looking at it. So we can see that as normal, the temperature is dropping as it gets farther away from the heat source. The temperature always does that. So as it gets further away from the heat source, temperature drops. And then this is aluminum intake. So as it goes to plastic is a very good thermal insulator, so it doesn't conduct heat very well. So that's another thing that we could do, is we could make this intake out of plastic, but it's very, very close to this hot exhaust. So that's a difficult thing. And also it's bolted directly without, obviously it has a manifold, and obviously it has a seal, but it's bolted directly up to the head. So it could melt that plastic, but you can see here that it is indeed up to about 170. So it goes from about, we can see the temperature drop here. It goes from about yellow, so that's like 214, 210 to 200. And it comes up, starts to go lower, 186, 185, 170, 150. And then it just kind of stays at 150 up here, because that's pretty much what it was. That's probably the ambient temperature inside. You see here I'm moving around. So what I'm thinking there is, one of the things that we should look at is possibly making that intake for the turbo out of plastic, or if this is your car and your daily driver, you might want to look at possibly coating that inside of that intake with something. So I'm trying to think of what I'm going to coat that inside of that intake with something, because it could be as hot as it wants on the outside. I really like the idea of it being hot on the outside, because basically I'm getting that engine heat away from the engine. so it doesn't stay inside of the engine. So I'm sucking that heat up and into the manifold, right? Into the outside of the manifold. But I want to insulate the air from the outside of the manifold, so that way the air does not pick up the heat through convection, which is again a stationary object, which in this case is the intake, versus a moving fluid, which is the air that goes in through there and then goes into the engine. Because also that would be a great cooler, is if we had the air cool the engine, because it's not a very good cooler if the air comes through and then goes into the engine, is already heated from the manifold, so it's taking that heat that it already gave up and bringing it back into the engine. Instead, I would rather have it be cold outside air come in to the engine, take that heat, and then dump it outside, right? And that way we'll get a better burn. It's going to smoke less often because our air is more dense, and we could do calculations later to see how dense that is. And so now what we're looking at is that issue that I mentioned a few videos ago, where I had some issues with hot water getting into the car, going through the heater, and causing hot air to be shot out of the vents. So what I'm looking at here is, this is actually an interesting way of looking at the temperature of if this thing is indeed leaking. And it does look like my valve is actually leaking, because we can actually see through the hose and tell that it's hot. Obviously we could touch the hose. You can do that as well. I mean, that's a way cheaper way of doing it, but it's a very nice way of visually looking at it, right? I mean, in actuality, I would turn off the car, wait for it to cool down a little bit, then touch that hose, because again, that's a rubber hose, so it's not going to burn you that bad, because it's not a metal hose, and then touch the other hose and kind of compare the difference, or even use a regular IR thermometer to kind of see. But this is why I like this, is that we could see it all at once, and it's a very good thing for testing purposes as far as looking at the uniformity. And this is one of the reasons why I have this instrument, is for my small business and also at work, is to be able to see temperature deltas all at once and see it in a spectrum format. So we can see here that the inlet hose is the hottest at about 165, but way lower than the engine at 217. So it's about 165 here. The car normally runs at 190. But again, that's looking at the overflow. My probe is at my overflow. So about 185, 190, or even 190 plus a little bit. So we're seeing that here it's 165. So it has cooled down a little bit since I turned it off. I think it was sitting for 10, 15 minutes or something like that, or 5 to 10 minutes. But you can see here that this hose is pretty cold, about 138, something like that. But this one, we have a little bit of a leak coming through here. So coming through, and then coming through there. But it's not coming out, so it's not going through and then coming out. I can't remember. Yeah, this has got a return line. So you can see that here it's got to have some sort of bypass. You can see here, I like how it did this. So this is the hottest area in the scene. And then you can see here it actually scaled it correctly. So here is about 150 degrees, 150 degrees or so, 150, 160, something like that. And then we can see that this guy is a little colder, but still kind of hot, 140 degrees here at this valve. And the top one is about 130, almost down to 129, coldest in the scene. You can see that here it's about blue, light blue, so that's about 141. And then we can see here that it goes back, and so now we can better see the hose in here. So 141, maybe a little bit of yellow here, so 149, and this is 143 around here. And then we could see that here it's 147, 155 or so, and then here at 143, and then this is quite a bit lower. So we are getting, but what that means is that if this is the inlet and this is the outlet, we are getting some heat exchange. So there is some sort of fluid here. So now what I'm thinking is that, is it because the fluid is exchanging heat through the valve and down through here? but why wouldn't it exchange heat through here? So what I'm thinking is it is leaking fluid very, very slowly through here, and then back up. When it comes back up, it's already cold. So it is leaking fluid very, very slowly through here, and then it loses about, 100 and something. Loses about 130 degrees. But you could see that the rest of the scene is actually, 125, something like that. So it was very, very hot in this engine compartment. So it might just be that it heated up the rubber because it was so hot inside the engine compartment. Because I've yet to open up any of the extra spots, any of the extra vents inside of the radiator or anything like that. So yeah, we can see here, down here, it's still 150 something. You can see here there's a metal hose, and it goes into rubber, metal, rubber, and then the valve. Okay, so this, where are we at now? Okay, so this is the side. This is that hole in the transmission. Here is a probe that goes in for temperature. Here's another probe. And we can see here the exhaust. And the head itself is like 100 and it's got some yellow, so maybe like 200 degrees Fahrenheit. So very, very close to the inside of the engine to the temperature. And down here, this is all the oil stuff. This is the oil filter here, and then up here is like you'll see the vacuum pump up here. But here's the rest of the block. Here's a block off plate. Here's a bolt head. And this is for another accessory. We can see here that oil is really, really hot in here. About 200 Fahrenheit, this can right here. You can see as the temperature drops, as it goes to the bottom. Super cool. Which is how it does it in actuality. So it goes from like almost white, almost 213, all the way down to about 170 at the bottom. And there you saw for a split second, this is actually the water, and then this is the dipstick with oil. And then there's the water pump. Here's the water pump. I don't know which one's the inlet, which is the outlet, but this is the water pump itself, and you can see the water line's actually cold here. Coming around. So this is the rest of the body of the car, and so now I'm looking at alternator is blue, not hot at all. And then down there, that is the water pump, the stem of the water pump. You can see about 186 Fahrenheit. And then down here, I think that's the harmonic balancer down there, and the pulley. And then here you can see a couple of bolts. There's a bolt head that's almost 190 degrees Fahrenheit there. And then here's the motor mount. Motor mount's red hot. So motor mount, this is the rubber part of the motor mount inside the engine here. This is 184 degrees Fahrenheit and then 170 degrees Fahrenheit here. So I guess this is conducting massive amounts of heat, but it's getting stuck on rubber. Rubber, again, is a very, very low conductor of heat, so it does not conduct to the rest of the body very well. And then here is that you saw right there. That's the fuel filter. This is the fuel filter, and you could actually see this is a reflection, an IR reflection off of the filter itself. And so another thing that I wanted to test was, and right there, you can see that the injectors are actually not that hot. The injectors start to get, and then this is the injectors, that's a loop here. The injectors are actually not that hot. And then this is the vacuum pump. You can see the vacuum pump that I'm not using because I don't have a solenoid for my power brakes. You can see even that's really, really hot. There's a hole in the transmission. There's the speedo connector. Here's the battery. And the battery, I was actually very shocked. But what I'm thinking is that this has a different emissivity. That's why it shows so hot, because I don't think the battery is 175 degrees Fahrenheit. And then there, that little red hot corner. And so now what I'm doing is I'm trying to look inside that trough to see if we could see that indeed that engine bay is getting hot, and that is why that section is getting really, really hot. So you can see it's struggling to adjust. You can see that it just shows that it's very, very cold in there. About 103 degrees. So that piece right there is about 103 degrees. And I would say that that's probably about right. But you can see that it doesn't drop entirely. This is the rest of the outside of the car. And it's saying that the outside of the car is about, and that's my hand here, so that's about 95. And you can see that the camera is struggling because pretty much everything is the exact same temperature. So the camera again struggles when everything is the same temperature. It doesn't do that great. Okay, so there's the overflow, and you can see overflow is cold. And here's outside, kind of cool. And you can see that it kind of freaks out because it's a very, very narrow window between 101 and 170, so it struggles to get all the temperatures, and you see quite a bit of... And then this edge right here, that's the corner of the radiator, so that's where all the fluid goes in, and then these are all the fans. These are all the fins of the radiator itself. Anyways, so that is the starting, kind of a cool look at IR camera with respect to car stuff. So definitely need, this is the first time working with it, so the next time, probably this next weekend, it'll be more focused on some things to fix. So number one that we see is we are indeed leaking heat into that tube that goes inside the vehicle and is used in the heat exchanger, and it is dumping heat inside the vehicle. So that's why I'm getting that 2 degrees through my thermocouple reading on the inside, 2 degrees more than the outside temperature, 2 to 3 degrees, is because that tube is leaking heat inside. So either that guy is not the greatest valve, even if it's brand new, or it's not closing all the way. So we could do a couple things. Number one, we can test it. We could buy a brand new one and see if we close it all the way, will it indeed close? Is it something, if we look inside, is it like a metal valve where pretty much if you have water on one side, water on the other side, it's going to conduct right through the valve anyways? Or is it, even with it's brand new, is it leaking? That's number one. Number two, we see that there's massive amounts of heat inside the transmission. And there's not a lot of ways that the air could get out of that transmission hole. So it's getting very, very hot in there. So either we need to figure out a way of getting some air in there to vent that area to let the hot air escape, or we have to start running ceramic. The next clutch will probably be ceramic, just to compete with that temperature. We do indeed see that we are getting quite a bit of heat transfer from the engine into the intake. We can see that's not as much as we originally thought, probably because it has some sort of cork, a cork gasket there, and cork is not a very good cork is not a very good conductor of heat. So that guy is probably there that prevents it from conducting heat through that cork, through that piece of cork. So that's probably why our temperature is quite a bit lower than the engine block itself. So that's good, but we still see that we are getting a lot of heat through that component and into our air. So we can calculate using some of the numbers that we know as far as the flow of air going through there to figure out how much heat we're actually pulling and how much heat that air is actually using to change temperature, which are obviously all not very good. It's not good to have your intake air change temperature. It drops the density of your air, and thus you are going to lose performance, and you're going to lose air density, and if you get on the gas too much on the diesel, it is going to smoke. So those are some issues that we're going to look at, and when I have something more focused, I'm going to do the infrared analysis on that, and so we could move forward. The next analysis I want to do is, again, that intake into the car, and maybe try to do brakes. Try to look at temperature of brakes when I get the vented rotors. And I'll talk more about that brake swap here coming very, very soon when I start, when I get enough footage of that. Alright, anyways. So this is Steven from Steven's Classic Garage. Thank you guys for watching so much, and I'll see you guys next week for some more videos. Take it easy. Peace.